Hello everyone, the objective of this video is to use one-way analysis of variance using the Jasp software. So as you can see on screen, we have 30 cases. 10 cases were treated with an element A, another 10 cases were treated with an element B, and the rest of the 10 cases were treated with an element C. The objective is to determine whether the tumor size of these 30 cases differs significantly. Remember, we have three groups, A, B, and C. And on the next column, you can check on their respective tumor sizes. So in research, probably you may ask the first question, what is the average tumor size of the cases treated with an element A? Another question would be, what is the average tumor size of those cases treated with an element B? And for the third question, for those cases treated with an element C. The fourth question would be, is there a significant difference in the average tumor size of these three groups or among these three groups? Remember, the Jasp software cannot successfully import an Excel dataset. So all we have to do is to save our file in a .csv format or a comma-separated value file type. You click File, and then you click Save, your desired file name, and remember to save this in a file format, comma-separated value. Please remember where did you save your file. In my case, I saved this file in the desktop. This is the welcome home screen of the Jasp software. The newest version is Jasp 0.14, and Jasp is an open source project with structural support from the University of Amsterdam. The first step that we are going to do to successfully import our data, click these three bars on the leftmost portion of the screen, click Open, click Computer, and then click Browse. Please remember where did you save your file. In my case, I saved the file in the desktop with the file name, tumor size, and then click Open. We have successfully imported our dataset. For us to run the ANOVA, click ANOVA. This is between t-test and mixed models button. Click ANOVA. You will be asked on your dependent variable and your fixed factors. Your fixed factor is also called as the grouping variable or your independent variable. In this case, our grouping variable is treatment. Remember, we have three treatments. Those who were treated with an element A, B, and C. And our dependent variable is the tumor size. Automatically, the Jasp software will give you the result of the analysis. Remember, the first, second, and third questions are asking on the average tumor size of the cases treated with elements A, B, and C. To answer that questions, all you need to do is to click Descriptive Statistics, and on your right side, it will automatically give you the result of the analysis. Descriptive Statistics showed that those cases treated with an element A has the least tumor size as compared to those who was treated with elements B and C. Result of the ANOVA shows that the p-value is less than 0.05. Others are setting an alpha level of 0.01, but let us try to set 0.05 in this example. And since our p-value is less than 0.05, that means to say that the tumor size of the 30 cases treated with different forms of elements significantly differ. If the result of the ANOVA revealed a significant difference, we need to perform multiple comparisons or post hoc tests. In this case, we are going to click Post hoc test. The post hoc test is between contrasts and descriptive plots button. Click Treatment, and using this arrow, drag this variable into the right side. Automatically, go into the lower level of the descriptive statistic table, There you can see the result of the analysis. This is the result of the post-hoc comparisons showing the difference between A and B, between A and C, and between B and C. Let us interpret this table one by one. For tumor size treated with the element A and those who were treated with an element B, the p-value is 0.004. This means that the tumor size between these two groups is statistically different. And when you go back into the result of the analysis, those who were treated with an element B, the tumor size was 3.4 and 1.7 for those who were treated with an element A. And if you're going to compute the difference of these two, that is 1.720. The question, which of these two elements is considered to be better in reducing the tumor size? In this case, element A, with an average tumor size of 1.7, is significantly better as compared to element B. What about element A and element C? Between these two elements, the p-value here is less than 0.001. Still, the result is significantly different. And if you're going to check on the descriptive statistics, for letter C element, the average tumor size was 3.790 and 1.7 for those who were treated with an element A, or giving a difference of 2.090. So 3.790 minus 1.70, the average is 2.090. And that is statistically significant, or the difference between these two treatments is considered to be significant. And therefore, element A is better as compared to element C. Between elements B and C, the result is not statistically significant, and therefore, either of these two treatments will be used to reduce tumor sizes. Remember, you can only perform post-hoc tests or post-hoc analysis if the result of the ANOVA table is considered to be statistically significant.